Hi, this is Janakireddy Dubbaka, Physics Rapid Revision for Neet and Mains. This is lecture number 2 from Dual Nature of Matter and Radiation. In this lecture, we are going to discuss photoelectric effect. Here, photoelectric effect, it is a phenomena of ejecting electrons by falling the light of suitable frequency on a metal surface. Ejected electrons are called photoelectrons, and the current flowing due to the photoelectrons is called a photoelectric current. This effect was discovered by Hedge. Laws of photoelectric effect were given by Leonard. It was explained by Einstein using the quantum theory of light. Whenever a light of suitable frequency is incident on a photosensitive metals, here electrons are ejected from this metal. This phenomena is called photoelectric effect, and the ejected electrons are called photoelectrons, and the current due to this ejected electrons is called photoelectric current. Here in a light is having discrete energy packets. These energy packets are called quanta. Each quanta of energy is equal to h nu. Here whenever light is incident, here one electron can absorb one photon only. Whenever the electron absorb this photon of energy, it will eject from the surface of the metal. Whenever the electrons are ejected from the metal surface, the surface becomes positively charged. Therefore, that positively charged metal surface will attract this electron. Therefore, again the electron come back to the surface of the metal. For example, if the energy absorbed by this electron, which is greater than electrostatic attraction force, then it comes out of the metal surface. That minimum energy needed to eject the electrons, that minimum energy is called threshold frequency. Therefore, that minimum energy is called work function. For that work function, there should be some minimum frequency. That frequency is called threshold frequency. Here, whenever this light is incident on this metal surface, this energy h nu, part of energy is used to eject the electrons, means used as a work function, and remaining energy is imparted to kinetic energy. This is the main idea of photoelectric effect. Here, laws of photoelectric effect, there is a lower limit of frequency called threshold frequency. This is for different metals, below which no photo emission takes place. However, the intensity of radiation may be. See, however, whatever the high of the intensity, but that does not depends on intensity, only depends on frequency. If incident light that greater than that minimum value means threshold frequency, then only electrons are emitted. Next, if the frequency is above the threshold, then the number of photoelectrons emitted per second is directly proportional to intensity of radiation. Here, as the number of intensity increases means number of photons incident per second on the metal also increases. Therefore, intensity increases the number of photons. This will increase the photoelectric current. Above the threshold frequency, maximum velocity or maximum kinetic energy with which electrons emerges out depends only on the frequency, not on the intensity of incident light. Therefore, maximum kinetic energy only depends on frequency, not on intensity. The emission of photoelectrons is an instantaneous process. That is, no time lag between the incident light and emission of photoelectrons. For example, in thermoionic emission, when a metal is heated up, after that electrons can be ejected. But whereas in photoelectric effect, there is no time lag. Whenever the photons are incident on the metal, spontaneously electrons are ejected from this metal surface. Here, work function means the minimum energy required to eject the electron from the metal surface is termed as work function. This property of the material on which light falls. This work function pi is equal to h nu naught. We can write a pi r pi naught. This is h nu naught. H nu naught means threshold frequency. Another one, pi is equal to hc by lambda naught. This lambda naught means threshold wavelength. Threshold wavelength means the maximum wavelength below which only electrons are ejected. See, it is a reverse to photo frequency. Threshold frequency means the minimum frequency above which only electrons are emitted. But threshold wavelength means the maximum wavelength below which only electrons are emitted. This is called a threshold wavelength. Therefore, for a work function, there are two formulas: pi is equal to h nu naught, another one is pi is equal to hc by lambda naught. Here's a very, very important one. When nu greater than nu naught and lambda less than lambda naught, photoelectric emission will takes place or will start. This is the condition. While doing the problems, you have to first check whether it is greater than work function. If frequency is given, if wavelength is given, that wavelength, incident wavelength should be less than maximum wavelength. Next one, Einstein photoelectric equation. Here, in the photoelectric effect, an electron absorbs quantum of energy h nu radiation. If this quantum energy exceeds the threshold frequency required for an electron to escape from the metal surface, then the electron will be emitted with maximum kinetic energy. Therefore, here incident energy h nu used as in two ways: some energy to overcome the work function, that is pi, and remaining is impart to maximum kinetic energy. This is Ke max. This equation is called Einstein photoelectric equation. Here, the kinetic energy of the electrons emitted range is in between. The minimum energy is 0. Maximum energy means Ke maximum is equal to h nu minus pi. Therefore, range of kinetic energy of photoelectrons is in between 0 to h nu minus pi naught. Minimum energy 0, maximum energy h nu minus pi naught. Next one, experimental study of photoelectric effect. Here, electrodes are emitted by a plate, electrons are emitted by a plate C. This is called a collector, and the plate A as an emitter, and this plate A is called collector due to the electric field created by the battery. See, this plate is called cathode and it is connected to negative terminal of the battery, and this plate is called anode and it is connected to positive terminal of the battery. Here cathode is called emitter. Why? Because it emits the electron. Here it is called collector. Why? Because it collects the electrons from the emitter. See, here this is connected to positive plate. Here it is an ammeter. It will measure the photoelectric current. Here is the voltmeter. This will measure the potential difference between cathode and anode. Due to this resistor, we can increase or decrease the potential between cathode and anode. Here, whenever the incident light is incident on this cathode, electrons are ejected from this metal surface. Here, from that electrons, some electrons having zero energy and some electrons having maximum kinetic energy. That maximum kinetic energy electrons will reach the anode. There is a photoelectric current can observe in this ammeter. Even there is no potential difference between cathode and anode. Means here whatever the electrons are released from this metal surface, from that some electrons having maximum kinetic energy, that maximum kinetic energy, even though there is a zero potential difference between anode and cathode, that electrons can reach the anode. Therefore, we can observe the photoelectric current. Therefore, even though your potential is zero, there is a current in photoelectric current. For example, here 20 electrons are released from this metal surface. From that, 5 electrons having maximum kinetic energy, that 5 electron reaches to anode. As the positive potential of anode increases, the number of electrons reaching this anode also increases. Okay, out of 20, 5 already reached. Remaining 15, as the positive potential increases, one by one reaches to anode. At one's potential, all the electrons emitted from this cathode reaches to anode. After that, if there is any increase in potential, even though there is an increase in potential, but current becomes constant, that maximum current is called saturation current. This is for potential. Anode is positive potential. Here at C, at cathode, kinetic energy minimum is 0. At A, kinetic energy minimum is 0 plus EV. 0 plus EV means this EV is nothing but work done by the battery. and at C maximum kinetic energy is h nu minus pi. But at reaching the anode, this is h nu minus pi plus EV. Plus EV is the work done by the battery. For example, when anode potential is negative with respect to cathode, see at C, Ke minimum is equal to 0. Here, when anode potential is negative, it will repel the electrons. Therefore, some electrons having maximum kinetic energy that will reach the anode. But as the negative potential of anode increases, even though the electrons having maximum kinetic energy, even that electrons also cannot reach the anode. In that case, photoelectric current is 0. That potential, negative potential of anode is called stopping potential. Here, for negative potential of A at C, kinetic energy minimum 0. Therefore, as the negative potential increases, no electron can reach the anode. Therefore, here K minimum also 0. Next one, Ke maximum is equal to h nu minus pi. But at anode, here Ke maximum is equal to h nu minus pi. Here work done by the battery is EV naught. Therefore, minus EV. This is the work done by the battery. At particular potential, that the negative potential V naught, even maximum kinetic energy electrons also does not reach the anode, means maximum kinetic energy at anode is 0. See here, Ke max at C is 0 when this V becomes V naught. Therefore, here this is 0, h nu minus pi, this V becomes V naught, EV naught. Therefore, h nu minus pi is equal to EV naught. This h nu minus pi is Ke maximum. Therefore, Ke maximum is equal to EV naught. This is maximum kinetic energy in terms of stopping potential EV naught. This is the experimental study. Here, effect of potential on photoelectric current. As the positive potential plate positive potential of plate A gradually increases, photo current starts increasing and reaches to maximum value called saturation current. See here, even potential is 0, current starts from here, that is due to maximum kinetic energy electrons. As the potential increases, current increases, and after that it becomes constant. This constant is called saturation current. When the negative potential is applied to plate A, photo current decreases to 0 after certain negative potential called a stopping potential. Here this is positive potential, here it is negative potential. As negative potential increases, current decreases and finally becomes 0. This where the current 0, that negative potential is called a stopping potential. Therefore, here Ke maximum is equal to EV naught, that is h nu minus pi. Next one, effect of frequency of incident radiation on stopping potential. As the frequency of incident light is varied, we obtain different values of stopping potential, but the value of saturation current is kept same by adjusting the intensity of incident light. Here, incident light intensity is constant, but frequency changes. For this frequency, here is a stopping potential. For this frequency, here is a stopping potential. For this frequency, here is a stopping potential. See, here nu3 greater than nu2 greater than nu1. Therefore, this is the stopping potential. Therefore, stopping potential depends only on frequency, not on intensity. See, the energy of emitted electrons depends on the frequency of incident radiation. The stopping potential is more negative for higher frequencies of incident radiation. Therefore, higher the frequency, higher the stopping potential. Next, this implies that greater the frequency of incident light, the greater is the maximum kinetic energy of photoelectrons. Consequently, we need a greater retarding potential to stop them completely. Therefore, higher the energy, we need a higher the retarding potential. Therefore, here stopping potential only depends on frequency and does not depends on intensity. Therefore, stopping potential depends upon energy of incident photon and threshold frequency of the metal. Here, the photoelectric current is directly proportional to number of photoelectrons emitted per second. This implies that number of photoelectrons emitted per second is directly proportional to intensity. See, as the intensity increases, number of photons increases. As the number of photons increases, photoelectric current increases. Here, intensity increases, photoelectric current increase. This is the relation between photocurrent and intensity. Here if you draw the graph between stopping potential and frequency, here Ke maximum is equal to h nu minus phi, this Ke maximum is equal to EV naught, therefore h nu minus phi, V naught is equal to h by E into nu minus pi by E. Here V naught is taken on y axis, frequency is taken on x axis, this is a straight line, that is y is equal to mx plus c. Graph is straight line, y is equal to f. When you compare these two, here m is slope, here slope is h by E. Whenever a graph is drawn between stopping potential and frequency, the slope is equal to h by E. Here h constant, E constant, therefore slope is constant, same for all the metals. And c is nothing but y intercept, that y intercept is pi by E, therefore work function by E, this is work function by E, this is for metal A, this is for metal B. Here is the stopping potential, here is the threshold frequency, and there is threshold frequency. For example, this is threshold frequency nu naught 1, this is threshold frequency nu naught 2, therefore threshold frequency nu naught 2 is greater than nu naught 1, and also y intercept also greater than. This is a graph between stopping potential and frequency. See, here is the graph between Ke maximum and frequency. Therefore Ke maximum is equal to h nu minus phi. When you compare with y is equal to mx plus c, therefore m slope, here is h, therefore slope for this one is h, here h also constant, it is same for all the metals, and y intercept is work function. Therefore for this is metal B and this is metal A, here theta is slope, that slope is h, and y intercept is work function. This is about the graph between maximum kinetic energy and stopping potential. Hi student, this type of lectures are going to available in my app, that is DJR Physics Sir. You can download this app from Google Play Store. I'm going to add all these lectures in my app after November 10th. So these lectures are very important. So along with the recorded video lectures, I'm also going to publish my class notes, short notes, and also my book, that is physics short notes mapping with NCERT and PYQs. So this is very useful for students, those who are preparing mains and Neet. This is a rapid revision course. First I'm going to upload the important more weightage chapters, recorded lectures, and class notes, and also my book, that is physics short notes. So every year more than 15 questions for mains appearing from my book, and for Neet around 25 to 30 questions directly from my book. It is very useful in this time span, and is 2 months or 2.5 months. You can revise all the important topics. Please download my app, that is DJR Physics Sir from Google Play Store. Thank you.